Bismillahirrahmanirrahim. As we were discussing about stereochemical language, and last time in our previous lecture we did studied about the wedge dash diagram to show the stereochemistry of the compounds. Remember, the wedge dash diagrams show very clearly which groups or atoms are directed in which directions. For example, we studied that wedge means that the group attached to this wedge is coming out of the plane of page towards the viewer, and dash means that the group is directed backward from the viewer into the screen or page, means behind the plane of paper, while the lines indicates that the groups attached to these lines are along with the plane of paper. For example, in case of methane, we did study that two hydrogens are along the plane of paper. One of the hydrogen is projected towards the viewer, and one of the hydrogen behind the screen is projecting behind the screen, which you are very clearly see in this three-dimensional structure, that this hydrogen is backward, this hydrogen is in front, and these two hydrogens are directed along the plane of paper or screen. Now come to some other modes of representation, the stereochemistry using symbols. The next projection style is the sawhorse style, which is named sawhorse as it resembles with the sawhorse of the carpenter, as you see in the picture clearly. Now come to the molecules. These are also similar to wedge dash diagrams, but in these cases the shading is not denoted and a smart drawing is used instead of shading. For example, in case of ethane, you can see that this ethane resembling with the uh, carpenter's sawhorse stool. Clearly it is shown that two hydrogens are at the position in front of each of other. These two are in front of each other and these two are in front of each other, and clearly it is shown from its three-dimensional model. You can see that when you rotate the molecule, every hydrogen is covered by the in front hydrogen. This form of ethane is called eclipsed ethane, where each of the hydrogen is covered by the second hydrogen. A second form of ethane is also exists, as denoted in this diagram. You see that here this hydrogen is not covered by this hydrogen. The whole of the group is rotated. So this type of structure is originated when a methyl group is rotated through the sigma bonds. As a result of this, the geometry of the molecule changes from eclipse to staggered form. Now you see that when you rotate the molecule, the behind hydrogen is not covered but lies in such a manner that when it is not covered by any of the hydrogen, And not only this, but the other hydrogens attached to backward carbon, they are also unprotected and can be seen from the front side view. This is the staggered form of ethane. So they are well denoted by the Sawhorse diagram by a smarter drawing. In case of propane, the Sawhorse projections are also shown. The group 2 of the carbon are denoted by the Sawhorse classical Sawhorse diagrams as we studied in the previous diagram, and the methyl group is denoted here in as a upward direction by a regular bond. And when you see the three-dimensional structure of the compound, you see that in the eclipsed form, the hydrogens are covered, and this one is the methyl group which is projected at upward direction. And in case of staggered propane, you see that no hydrogen is covered by the other hydrogen. You can very clearly see between the carbon number 1 and 2 that hydrogens are projected in such a style that they are visible from front. Each of the hydrogen is very clearly visible from the front side, and this is this one methyl group which is projected upward by and joined by this bond. The Sahar's projection allows better visualization of the three-dimensional geometry by a classical 2D diagram. And in this diagram, the interactions between groups on adjacent carbons are shown very clearly. The backbone carbons are represented by diagonal line, and the terminal carbons are shown in groups. As we see that these are the terminal groups which are shown in group, while the backbone is represented by diagonal line in the diagram, where we see these are the backbones. This is the terminal carbon. This is the terminal carbon, and of course it requires a smart diagram. So one should be able to draw a clear diagrammatic view or picture using his pen or pencil. The next type which we are going to study is the Fisher projection. Fisher projections are abbreviated structural forms, and they allow to convey valuable stereochemical information to a chemist without them having to draw a 3D structure representation of a molecule. In these, cross diagrams are used which represent the stereochemistry of the molecule very clearly. As you see, this is the diagram of glyceraldehyde molecule in which cross are used. There are two types of lines, vertical lines and the horizontal lines. And remember that this type of projection is used for chiral center, and chiral center is that center where the group is carbon is attached to four different groups or atoms at four sides. For example, in this side, in the glyceraldehyde, this carbon is the chiral carbon, which is shown in this cross at the middle position. At one side, it has a hydrogen atom. At the other side, it has a CHO group. At this side has a hydroxyl group, and the fourth side is covered by CH2OH group. So this one is the chiral carbon. or this is also known as asymmetric or stereogenic center of this molecule. The Fisher projection of the molecule is derived by considering the more accurate 3D representation using wedges and assuming the convention that horizontal lines represent bonds coming out of the plane of the paper and vertical lines represent bonds going behind the plane of the paper. So horizontal lines, these are the horizontal lines, they show that the groups attached to these are coming out of the plane of paper towards the viewer. These two graphs are which are denoted by the horizontal lines. They are they are located towards the viewer from the screen or the paper towards the viewer, and the vertical lines from upward to downward direction, these groups are projected behind the screen or the paper. It is very clearly seenable in the given picture. For example, this is the Fisher projection and this is the wedge dash representation of the glyceraldehyde molecule. Sorry, the 2-hydroxypropanol molecule, and you see that the horizontal lines indicate that here in this diagram as a wedge, and the vertical lines and the groups are shown here as a wedge. And when you see it in a three-dimensional structure, you see that this hydroxyl group is projected towards the viewer. This hydrogen in both cases is also towards the viewer, while the CHO group and the methyl group, they are projected in backward direction from the paper or the screen. You can clearly examine it by rotating the molecule in various directions. So this is the situation in 2-hydroxypropanol in Fisher projection or wedge dash representation and in 3D model representation. So you will clearly understand that what does the Fisher projection means, or the lines which are um, written in Fisher projection, how they are oriented in the uh, space. The next is the Newman projection. This is also a very famous projection which is used to describe the stereochemistry of simple molecules. You see that in the Newman projection, it is drawn along a particular bond in a system between the carbon-carbon bond and arranging the substituents symmetrically around the atoms at each end of the bond. In this case, in the Newman projection, the front carbon is indicated by a dot and the groups attached are indicated by the lines, while the behind carbon is represented by a circle and the groups attached to it are uh, shown using a line attached to this circle. So these hydrogen, this methyl group and this hydrogen, they are attached to the backward side of the carbon, and this one is the carbon which contains hydrogen at all sides and is located at front side of the molecule towards the viewer. This is the representation of dot and a circle. This is called Newman projection. Dear viewers, hope you have understand the different projections modules clearly, which I have explained to you using um, various two-dimensional and three-dimensional models and diagrams. We will continue our course of stereochemistry in the subsequent coming lectures. You can put your questions or answers directly to me on my WhatsApp number or through email, which is visible on the screen. Thank you.